Hello, good morning. Welcome to the DataPorts workshop organized in this year's DataWeek. My name is Christos Gizelis. I'm an impact manager of DataPorts project, and I would like to welcome you all of you that are here in this year workshop. The title of our workshop is Joining Research Forces and Create the Future of Ports and Maritime based on data-driven services, defining the strategy. Let me tell you a few things about this workshop. This workshop is a step forward of last year participation of DataPorts project in DataWeek. That was about unleashing the potential of ports and maritime logistics via data-driven solution opportunities and challenges. This year, it is our privilege to have several other projects with us. Besides DataPorts, ASSIST-IoT, Cyrene and VesselAI will be joining forces in an attempt to define the strategy for the data-driven services in the seaports and maritime of the future. The seaports of the future is about data-driven services. It's a creation of a new ecosystem, an expanded ecosystems where there is a place for many stakeholders. So this workshop elaborates how data-driven services and applications, including AI-based cognitive solutions, can help all the stakeholders in the logistics, ports, and maritime sectors to improve their operations. It will also help to identify and understand the challenges that we must address in order to facilitate and adopt all these solutions. Let me present you the panel of today's workshop. The first speaker, Santiago Cáceres, Project Manager of DataPorts Project. Dora Kalipolitou from Zelus, representing the Cyrene project. Spiros Mouzakitis, presenting the VesselAI. And Carlos Palau from UPV, presenting the ASSIST-IoT project. So now it's time to give the floor to the first speaker, Santiago Cáceres, the project manager of DataPorts project. Santiago, the floor is yours.
Thank you, Christos. So it's a pleasure being here. I'm going to share my screen. Okay, here I am. So yeah, my name is Santiago Cáceres. I work for ITI, which is a research center based in Spain, focused on all this cycle of the data. And today I'm going to make the first presentation of this workshop. It will be about DataPorts, which stands for Data Platform for the Cognitive Ports of the Future. And in this presentation, I'm going to make a quick overview of what the project is about. I'm going to show you, give you some insights about the pilot sites and the demos that we are working with to show the full potential of the things that we are doing. And I will finish my presentation pointing out the results of the project, okay? So just before anything, just setting up the scene. So we have here the Port of Valencia, which is a good example of a modern port in Europe, as there are many others, okay? And these are very complex ecosystems where many entities and many organizations are collaborating on a daily basis with several objectives. So, so if we focus, for example, in logistics, we have many actors there, like the port authorities, shipping agencies, terminal operators, freight forwarder. All these stakeholders inside the port, they have their own assets in terms of infrastructure, in terms of data that they manage. We may find IoT platforms inside the port, cloud servers, on-premise IT servers, mobile devices going around. So there is a huge amount of information that is generated based on this collaboration that these organizations have. Sometimes, and one of the things that we consider in DataPorts is that the data is not exploited at its full potential. So there are, of course, some collaboration between these entities, but there are some barriers that make hard to share and trade data inside the port. It can be the lack of trust in the systems they are relying to share the data, or it can be other reasons, but there is not full potential. So we want to take these modern ports to the next step to have the full potential and to extract the full potential that the data sets may have, okay? So in this context is where DataPorts emerge. And what is exactly DataPorts? So first of all, we want to take advantage of this huge amount of data generated in modern European seaports. And how can we take advantage of it? So our proposal is to build an industrial platform or a reference industrial platform where data coming from different sources and different entities can be combined, and we have a very clear aim, which is to improve the existing processes, so to make them better, to make them more efficient. Okay. And on the top of that platform, we are building what we call cognitive applications, which are mainly artificial intelligence based applications, which forecast may forecast or how the port can behave, and will and helps decision makers at the port to make the right plans on their daily activities. And last but not least, if we introduce such a platform inside this complex ecosystem, we have to make sure that everybody is taking benefit out of it, and we are researching on new business models that may arise for having such an industrial platform. Okay, so I will be very quick on some metadata of the project. So we are a 3 years project, more than 6 million euros budget, more than 900 person months, and with some partners. So this is where we are. The project started in 2019. We are at the last year of the project, so we will be finishing by the end of this year. We came out at the beginning with the design and specifications based on the seaports requirements, and we delivered the first version of our platform. And now we are almost at the end of the second version of our platform, the final version. And at the same time, we are piloting and making the demonstrations right now. Okay. So this is the consortium which forms DataPorts. So we are a good complementary set of partners. You will see that it's a very Mediterranean consortium, since our pilots are Valencia and Thessaloniki, but I will come into details in a moment. So let me present our platform let me present you our platform based on these building blocks. So this, of course, is a simplification of the whole architecture. We have a complete set of specifications, but as our time is limited, I will just made some highlights about each one of these boxes and what these mean and what is the functionality behind. And in case you are interested, you can contact me and you can get more details offline. Okay. So if we go from the bottom to the top of the platform, so you see at the bottom we have the raw data, and there are 2 ways of sharing data and trading data through the platform. One is the most common one, I would say, which is peer-to-peer exchange of data. So you will go this way, where you see data sources, where the data is, and you will access the platform through the data access component, which data access, what does is to help you to go into the platform, your data sets. It builds some agents, and depending on the format of your data sets, you will be able to just take it very easily. So it's something that will help you to include your data sets into the platform. But there is another way to share data in the platform, and it is by using a blockchain network. So you directly put your data in chain. Okay. And of course, there are some considerations here in terms of scalability and in terms of privacy. But for some of the specific topics that are needed in ports, this can be interesting. to share data directly in chain. So I will give you a couple of examples when I talk a little bit more about our use cases. Okay. Then we have the data processing services, this big building block. We saw already the data access. Now we have here the semantic interoperability. So everybody who is inside the DataPorts data space should speak the same language. That means should follow the same data model. Otherwise, the communication will be difficult. So in the case of the semantic interoperability, it offers the tools just to transform your data so it is understandable for the rest of the DataPorts ecosystem. And the next module that we have in the data processing services are the data abstraction and virtualization. So what this does is a kind of pre-processing of your data, some capabilities of pre-processing, for example, cleaning your data or making other arrangements in the data sets on your data sets, so it is prepared for upper layers in the platform. Okay. Then we have the data governance services, and this set of modules, this set of components rely on a blockchain network. We have the clearinghouse, which is a log collection of what's happening inside the DataPorts ecosystem and inside the platform. So each time someone shares data or receives data, it is reflected here through a log. We have the data governance rules, which just provides you functionality on who can access data, during what time, for which purpose, etc. We are using here smart contracts to make this functionality a reality. Okay. We have the identity management for authorization and authentication inside the platform, and we have what we call here the IDS broker, IDS for the industrial data spaces broker. And this broker, what provides is a catalog of metadata, which is inside the platform. So you can see what others are offering, but just the metadata, of course. The data always remain close to their owners, following the IDS principles. Okay. Then we have the analytics services, where we have a couple of modules which provides models, all the things you need to build your models for building your applications based on artificial intelligence. And last but not least, at the top of the platform, we have what we call the platform service gateway and an IDS connector. So we are not really developing an IDS connector. We are using existing ones. We have been testing them, and we use it for the peer-to-peer exchange communication as a last step. So regarding this IDS, we like to say that our architecture is IDS friendly, but not IDS compliant. So we follow the same principles of the IDS, and we have much in common with them, but we are not compliant 100%. Okay. So moving now to the use cases. So we have the use case of Valencia port first in Spain. Here we have 4 different scenarios: the tracking of transport operations, where we are feeding the system with events that are happening to the vessels and in the port. The Port Authority data sharing and analytics services, which I will go into a little bit more detail in a moment. We are complementing some of the functionalities offered by the PCS of Valencia. We are extending them. Okay. And the last couple of scenarios, the sharing, verify, gross mass, and the data consignment node, are scenarios where we directly share data in the blockchain network. So in the case, for example, of the verify gross mass, in the port, there is the need of share the verify gross mass, what we call BGM of a container between many stakeholders. Sometimes there are discrepancies about the value of this BGM of a given container, and that can lead to some discussions about tariffs because they depend on the BGM. So if we put it in the blockchain network and this agreement between all of the entities that this need value, so that's something that really gets benefit, and they don't have disputes about this value. So these are examples on what the blockchain network can give real value to the ports. Okay. Then we have the Thessaloniki port in Greece. We have here 5 different scenarios. So we are developing a dashboard where for decision makers inside the port, when they have a where we aggregate lots of data coming from open sources and from others and from proprietary sources inside the port, so they can take some decisions and can plan based on what they see in the starboard. Okay, we are also using the DataPorts platform for the containers company, for the trucks company, for delivering permit IDs for container pickups of the trucks. Okay, and then there are a set of scenarios where we extract some interesting analytics in the Thessaloniki port. Okay. And second, and the last case is what we call a global scenario, which I will go into details in a moment. But what we plan to show with this global scenario is to see how scalable is this platform and how interoperable it is. Okay, so just to give you an idea of the things that we are doing in the ports. So, for example, in the Valencia port use case, these are some of the cognitive services that we have developed already. One is the real-time prediction of the estimated time of departure of a vessel. So they already have this value in their PCS, but it's not very accurate. So we are using artificial intelligence techniques to improve this value that they have in their PCS. Okay. We also saw the port occupation evolution. So how is the workload inside the port, and how is it is going to be in the following days or in the following weeks, so they can make plans and arrangements inside the ports. That's another of the cognitive services that we are offering to Valencia. Also, not only some statistics about the vessels, but also an analysis of the products that they are moving, the goods that they are moving inside the port. So how is the flow, the demand, and where are the origin and the destiny and so on. And also, we are not only doing prediction and forecasting, but also there were some needs inside the Port of Valencia. In some of their data sets, there were gaps. Sometimes the operators, when they click on the information in the data set and this fits the rest of the system, there are some values that are missing. So thanks to artificial intelligence techniques, we are able to fill in those gaps and provide more quality to the data sets. And thanks to the DataPorts platform. So yeah, we have a full set of dashboards for doing all these things and for checking all these things in the Port of Valencia. Okay. In the case of Thessaloniki use case, this is another example of cognitive services that has been developed within the project. This is a data-driven app for strategic and real-time decisions. So what we do here is to optimize a set of parameters based on multiple criteria. So we may have data sets from traffic conditions, weather conditions, and others, and we aggregate all this information and give some value to the operators. So in the screen, you see a screenshot, a capture of the application of a vessel visualization. So what you see there is the evolution of the port. So you see there some boxes and lines. These are the different vessels that arrive and departs from the port. And for example, you see those lines all the time that the vessel is remaining in the port, and the boxes, what it reflects is the real work when they are doing some work operations inside the port. And if they click, they can have more information in each one of them about which is the shipping line, etc. To show the scalability and the interoperability of the platform, we have the global use cases. So, for example, here in the smart container use case, we are equipping some containers with one of the technologies provided by one partner in DataPorts, in this case Traxens. It's an IoT box. So this sensor that it's attached to the container gives information about the position, the movement, the ambient temperature, if there is any door opening event inside the container, if there are shocks to it. So all this information at the end is fed into the DataPorts platform, and it's presented through cognitive applications to the operators. Okay. And then last example of the global use cases is one to show the interoperability. In this case, what we are doing is taking a commercial solution to port management, which is Posidonia, which is brought by another partner in the project consortium, ProDevelop, and used and connected to the DataPorts platform to enhance their capabilities. Okay, and we have selected an external port to the project, which will be testing the developments of the DataPorts platform, and this is expected to happen by the end of the year. Okay. So just to finish my presentation, some selected achievements in the project. Just in case you have you want more information, of course you can contact me, but there is already some public information available in our website. So just to point it out that you will find there some information about the specification based on seaport community requirements and challenges, details about our architecture, much more details of what I explained in this presentation about the use cases, some information about business innovation and new data-driven exploitation strategies. So everything, you have the link there, so feel free to go and download all what you want. And we will be finalizing the first version of our platform by the end of this month, and we'll be carrying out the demonstrations of Valencia and Thessaloniki until the end of the year. So the project still has some things to do. And with this, I finish my presentation. So I think we are taking questions at the end, Christos. So
exactly.
We can move to the next presenter.
You read my mind. Thank you, Santiago. Always very detailed, very informative, and always on time. Thank you. So let's move to the second speaker, Dora Kalipolitou from Cyrene project. Dora, the floor is yours. Thank you.
Hi everyone, thank you very much for having me here. Talking about defining a strategy and thinking about the future of ports and maritime, I will talk to you a little bit about Cyrene, which is focusing on the security part of these services and about trust and in the collaboration among partners, and of course at the end the receiver of this process, which is the delivery of goods and the client, of course. So a few words about the project ID. So Cyrene stands for certifying the security and resilience of supply chain services. It's also a research and innovation action. It will last 36 months, and we are already a little bit more than halfway through, since we started in October of 2021. Our total budget was at approximately 5 million, and our consortium consists of 14 partners, 3 of which are major players in the industry, and 2 of them constitute also our pilots, the CRF, which is the research center of Fiat, and focuses on the transportation, on the inbound logistics of their parts for making their cars. And the Valencia port, which in the context of our today's discussion is also like our port representative. We have 3 players from research and academia, and a number of SMEs, which are helping us with the technical and the theoretical elements of our project and deliverables. Now, a little bit more to the point of what we are trying to address. So as we all know, supply chain services are the enablers of global trade, and any disruptions may have a severe impact, as we all saw during COVID. And this is actually what we want to tackle, because as we speak, there is no structured, standardized, and trusted way to forecast, prevent, and manage interrelated and propagated cybersecurity vulnerabilities and threats. And this is because there are so many players and they have so many different environments they are working with. So basically, to take care of the cybersecurity of all the shared assets and objects and processes, it's super complex and super difficult to do. However, this is what we're trying to poke and put our finger on. And our vision, and therefore the value proposition that we want to suggest basically is exactly that, is to create, first of all, a dual risk and conformity assessment process that takes into consideration all these business processes, but also all the physical assets and investigates potential threats, vulnerabilities, and risks, and to have a Cyrene supply chain services certification scheme that unifies, if I can say, or even a better word, takes into consideration all international standards that may apply and comes up with a more aggregated rules and conformity requirements. Now, how we are trying to do that, we have like 6 objectives that we want to address, as you can see here. The first one is to create a tailored and risk-based security and privacy certification schemes. This tags next to what I said before. There are a number of them now, so we are trying to put them all in order and to organize them according to the needs of each partner. To develop a novel dynamic cybersecurity and privacy conformity process to support the different types of conformity assessment, because of course not everyone has the same needs and not everyone needs to be necessarily as extensive and as in-depth certified, depending on the services that they are going to use, and also depending on the vulnerability that they pose to the service. To develop a collaborative, multi-level, evidence-driven supply chain risk and privacy assessment approach, so that, yeah, I think this is more self-explanatory, so that there is collaboration and trust among the partners, of course. To specify modern simulation services to dynamically forecast, detect, and prevent supply chain cybersecurity and privacy risks, and define mitigation strategies, because of course it's good to know what is potentially dangerous and vulnerable, but it's also very important to have suggestions about what to do to tackle it. Otherwise, the recognition doesn't offer that much. To validate through real-life supply chain services, which is served by our pilots, of course, and to develop a set of best practices and standards enhancements for the cybersecurity and privacy conformity assessment for supply chain infrastructures, because the aim and the goal is not to be used only by the industries that our pilots represent, but of course by other industries as well. So to collect them and form more concrete, let's say, offerings, I could say that what we actually offer is, first of all, a security declaration process that enables trust among actors in a supply chain service value chain, so that from time zero, basically, we all agree on our goal and on the security level that we want to achieve, and on confidentiality, and we are good to share information about our assets, vulnerability processes, etc. Our shared assets, vulnerability processes, etc. Second, as already mentioned in the value proposition as well, a dual risk and conformity assessment process and the relevant toolkit to perform this process for supply chain services, a certification scheme that orchestrates this process, and an integrated platform where that the partners can use in order to perform all these actions that we mentioned before. Now, regarding this process and the scheme that we mentioned, there are 3 different levels that a partner can choose to conform with. The first one is the business target of evaluation, as we call it. The second one is a technical target, and the last one is the sector specific. The business target focuses more on the business processes of the owner of the supply chain service. The technical one takes into consideration all the technical, all the shared technical assets. And the last one, sector specific, is about the concrete part of the collaboration between the supply chain service owner and the participant into this supply chain service. So maybe in order to make it a little bit more concrete, the pilots will help in order to explain how all this link together. So for example, we have the supply chain service of the vehicle transportation for the Valencia port, where they coordinate all the vehicles that are in the port and want to go to another country. So there, the vehicle transportation service is a very complex service that has multiple sub-processes with a lot of actors, a lot of sub-processes involved in order to make sure that everything is in place and secure and also monitored. And a lot of assets that need to be connected with the logistics assets of the companies that are actually moving their vehicles, but also the authorities and other partners that want to know where these vehicles are, if they comply to certain rules, etc. So here we can imagine basically Valencia Port serving as a key supply chain service owner, and the assets that are monitoring all this process to be the one that would fall under the technical target of evaluation. And then CRF could be one of the partners serving the target of evaluation for the sectorial view, where they are using a subset of the processes perhaps and a subset of the shared items, and they need to make sure that they comply with a minimum security risk, and they do not pose extra vulnerability to the whole process. Of course, at the same time, we can see CRF as a supply chain service owner on its own, because that's why we use the inbound logistic process of themselves, because they collect parts from many partners and they want to follow a particular process as well to know where these parts are, to know also security levels of what these parts comply with, because they are getting into their own supply chain as well. So the same thing that we described for the ports then can be like utilized in another industry, like the one of transportation and the manufacturing. Speaking of the technical part of the value proposition, as we said, that there are two key items. So I will focus more on the methodology, which is split it in 6 major steps, each of which has a separate sub-steps as well. So we start, as we said, with the SDA agreement, where everyone defines and agrees on security levels and on sharing information. So we make sure that we conform as partners what we have agreed. The second step is the agreement between the partners about the services and processes and the target of evaluations for everyone that is involved. The third step is the one that actually performs all the tests regarding threat analysis for all the shared assets and prediction and vulnerabilities. The fourth has to do with, the fourth one is the one that focuses on vulnerabilities. They are together, threats and vulnerabilities. So the fourth one is the one that focuses on vulnerabilities of the separate processes and assets, but how this also combine in order to increase the vulnerability of the whole service. The fifth one talks about risks and the risk assessment of the whole service. And lastly, the final one talks about the mitigation actions in order to make sure that we improve the risk scores, and also comes out with a conformity result, let's say. It's important to mention here that this methodology and this tool can be used both as a self-assessment tool in order to see how we comply, but also by a third party in order to see whether someone conforms with a specific certification scheme. Here you see a little bit a high-level overview of our architecture. As you see, there are 5 key vertical layers where they tackle each of the technical assessments, if I can call them like that, addressing threats, dark web intelligence, attack simulations, vulnerability, everything that we said before, in order to see the risk, to comply the risk level of its partner and of the supply chain service as a whole. All these results of the separate tests are saved in the unified data management layer and are being pulled every time it is needed in order to go to the next step and eventually to suggest improvements. And of course, because we have multiple users that may be involved, like a security manager or the assessor, as we said before, but even on the level of the business target of evaluation, the business owner themselves, visualizations are super important. So we have like different views for each user. More information you can see also at our website, because as I mentioned, we are already more than halfway through of the project. So you can see there, of course, our first more in-depth deliverables about all these topics, and then you can get more information about that. I have included a little bit of a very, very small demo that we have, but I don't know how we are doing on time. Can I still show it? It's a very, very small one. Is it okay? So here is how the platform looks like.
Yeah.
Cool. And then here, basically, what you see, if it's playing, yes, what you see is how the whole collaboration actually starts. So the participant in the Cyrene platform can start actually putting the serving as a supply chain service owner, setting the criticality of the supply chain service as a standalone thing, the security level that they want to have everyone commit to. They can invite all the partners, of course, that they are about to participate to the supply chain service, and either invite them or find them in the ones that are already in the Cyrene platform. And after that, because they are the ones initiating the service, the process, I'm sorry, they're also sharing the information needed about verifying the assets, as we said before, and the security of the processes involved. And they're expecting the same from the other one. So all this information is collected in one digital document with all the necessary attachments for the partners to know what they are entering into. And it's being shared in order to be signed and set the grounds, let's say, for the collaboration. So, and we have a digital repository, of course, of what we said before. So here you see how the document is being created, basically. And that would be it, I think, for now. So in a nutshell, Cyrene aims to create trust within the supply chain ecosystem by identifying and the security level that everyone wants to commit to, and how each one of them conforms in order to have, according to a unified, as we said, certification scheme, in order to make sure that everyone feels trust and can proactively anticipate vulnerabilities and correct them. That's it. Thank you very much. Here, like a general link where, as I said, you can find all the information that you need, from social media to our website to our community in Zenodo, with all our deliverables and research work. And yeah, I will remain also in your disposal at the end of the presentations for any question, of course. Thanks again.
Thank you a lot, Dora. What we have seen so far is a data-driven platform that can exploit all available data to benefit the port authorities and all the stakeholders of the ecosystem. We have seen security solutions available, and let's see now the services available for the vessels. Spiros Mouzakidis is our next presenter, representing VesselAI. Spiros.
Thank you very much, Christos. And I would like also to thank you very much for inviting us to this session. It's always a pleasure to work with you. I'm Spiros Mouzakidis. I'm a senior researcher at the Decision Support Systems Laboratory of the National Technical University of Athens. Before we begin, I would like to ask the audience when they have the time to fill in a survey that we're conducting in order to gather your interest in the VesselAI research areas. So you can go to bit.ly VesselAI survey. It only takes 3 minutes in order to gather your feedback. We will share the slides later also, so you will be able to find the link also there. So a few things about the VesselAI. It started in January 2021. It's 3 years of duration. We are 13 partners from 6 countries. 6 pilot partners are pioneers in the maritime technology intelligence, and we have 7 technical partners with expertise in data engineering and analytics, HPC and AI acceleration, as well as artificial intelligence. So 2022 finds HPC, AI, and big data in the forefront of the maritime digital transformation, and the maritime industry needs to embrace it in order to meet the increasing demands in terms of safety, security, energy efficiency, environmental impact. Just to get a glimpse of these needs, there is still a considerable amount of incidents and accidents happening on the sea that is attributed to the human error. We all remember last year the accident with the incident with the Ever Given in the Suez Canal, but it caused a global, it had a global effect, not only in the shipping industry, but also in the global economy. And we have to utilize all our available intelligence tools in order to also address and deal with the energy, the climate, and the humanitarian crisis that we are currently living. So the key to address all these challenges lies within the research and development of novel technologies, including distributed and extreme scale data processing, with Hadoop in-memory databases, streaming SQL, parallel processing, all the advantages in the deep learning and reinforcement learning, the HPC and the AI computing advances. To take into advantage the large amount of data that is being generated by the maritime industry. So another concept that's gained ground the last years is also the concept of a digital twin. Basically, digital twin is a digital representation of a physical entity. The physical entity, such as a vessel or a subcomponent of that vessel, the physical entity generates real-time data from the sensors and feeds the digital model. So you can have a significant amount of optimizations in terms of time and money through monitoring and performing simulations and analysis of the assets and the process and the workflows on the digital model instead of doing that on the physical model. And another very important contribution of the digital twins is that they are able to provide data in order to feed and train also the AI models, especially when obtaining this data is costly or rare or very hard to obtain. So one of the problems is that the maritime industry has limited available effort, it is high cost, and they have limited expertise to experiment with all these technologies. And in terms of the technical challenges is how we can integrate the currently math-driven physics-based simulations with data-driven simulations in order to feed the next generation of maritime applications and digital twins. The efficient data processing of data, especially when we are talking about extreme scale data sets. The complexity in creating, training, and especially validating the AI models, for instance, for their bias. And also taking to advantage the capabilities from HPC infrastructure, which up until now, it was a different world that had its it needed special expertise and infrastructure. It was it wasn't easy to have a convergence between the data science world and the HPC infrastructure so far. So this is where VesselAI comes in, with the goal of creating and demonstrating a holistic framework that combines these technologies in order to perform extreme scale and distributed analytics for fueling the next generation of digital twins and maritime applications, including the vessel behavior and motion modeling, the analysis and prediction of the ship energy system design optimization, as well as many applications for unmanned vessels, route optimization, and fleet intelligence. We have 4 use cases. The first use case is led by marine traffic. Marine traffic is the products of marine traffic have to do with the past, present, and future of the vessel. The particular use case focuses on the present and future of a vessel, including that deals with many parameters such as the load condition and the vessel growth, the speed of the current voyage, the distance to travel, the distance hauled, the time to destination. And the future will have to do with the estimated time of arrival and route forecasting. So the key aspect here is to have a global route forecasting and to develop accurate and timely traffic prediction for an extended forecasting horizon, and how we can experiment with data-driven solutions, moving away from simple kinematic models by taking into consideration also dynamic data. And by creating such models, the idea is to incorporate this in the current products of marine traffic, including the fleet tracking and management, port congestion data and awareness, as well as visibility and support on the cargo delivery. And this will also be enable the users to have real-time notifications about the results of such prediction and forecasting models. The second use case, led by VTT, is about how we can utilize AI, big data, and HPC in order to automatically explore the design space to find the optimal design components of ship energy systems operating under real operating conditions. VTT currently has that digital twin simulation platform that simulates the energy flow within the ship. And the key goal here is how we can find the optimal design of such energy components in order to reduce time, efforts, and cost of ship energy system design and optimization process. So they will expand the platform, the digital twin, with capabilities in AI and big data analytics. The third use case is led by Masterly, Kongsberg, and Sintef Ocean and Sintef Digital, and has to do with autonomous ships in short sea transport. Usually when it comes to unmanned ships, the current research, there is a lot of work being done that has to do with the automation of the ships. The goal here of this use case is to support the operators in the shore control centers that actually monitor and plan the routes of the autonomous vessels. And the use case is in the Oslo Fjord, one of the busiest straits in Norway, between the Horten and Moss ports on a newly created shore control center. There are 2 use cases here. The first is to create, train, and deliver route predictions models using AI for nearby vessels until the sailing starts. So you plan the route of the vessels based on that predictions. And the second use case has to do with these route predictions and anomalies detection while the ship has the unmanned vessels are already shipped, and to alert the operators of the shore control center about findings. The fourth use case has to do with NAPA and their product fleet intelligence. And the key research aspect here is to provide route prediction and route optimization decisions based on dynamic information, such as weather, speed profiles, cost, fuel consumption, traffic, as well as port congestion modeling. This is currently the architecture of our solution. From the beginning, we took as a decision to not to have a hard-coded platform where everything is glued together, but to follow a flexible approach, meaning that everything is created in a flexible manner under a flexible machine learning and data processing pipelines. So starting from the data sources, we have reusable and modular components about the data ingestion and lifecycle management of the data for both batch data and real-time data. Thereafter, there is a data curation, anonymization, and semantic enriching of the data. In terms of the semantic capabilities, we have created tools that allow the reasoning queries upon the data. And we have a tool called complex event processing and lead discovery, where you're able to define what constitutes a complex event, for instance, and perform queries in there. In terms of the data storage, we are working on optimizing different data processing operations, especially geodetic operations, in order to make the queries more efficient, especially when we have to extreme scale analytics. All this data processing leads and serves the purposes of training the datasets using state-of-the-art technologies and creating models and training the models utilizing this data. These models include a library of pre-trained models that will be shared also, such as the route prediction, the traffic flow prediction, fuel consumption prediction, and many, many more. The models are then being served either as an API or library that can be incorporated within the applications. So after you receive the model and the pre-trained model, you can incorporate it in the existing maritime applications. So interoperability was a key aspect of us in order for the models to be easily consumed by any technology available currently to the maritime industry, and to be offered natively within their applications. Thereafter, we are also building a data analytics environment and visualization engine that allows the users to create an experiment with graphical data pipelines and machine learning pipelines graphically through an interface. You can see here the stack of our processing. And also the heavy work, like the training of the data and the serving of the data, is handled by the HPC infrastructure, and we experiment with different setups of CPU, TPU, and GPU in order to see also the convergence between the typical AI tools such as TensorFlow and PyTorch with the classical world of HPC and the setup. There is always a balance between the time taken when you're utilizing the native HPC technologies and when you're using a framework, framework on the software stack on the top of that HPC infrastructure. Again, I will say that everything that we create will be modular, and this is our key goal in order to be reusable by third parties, and we will share we will share the models as a service or either as a dataset, either as a Docker container to the AI for You platform. If you don't know it, the AI for You is the one-stop shop for AI tools and knowledge, and so you will be able to utilize components from the VesselAI platform within either from the AI catalog that AI for You has, or you can reuse it in a graphical way through the Akumus platform that currently AI for You platform has. So you can reuse specific components from the VesselAI platform in order to create your own pipelines or to utilize these models in your own applications. So we will be very happy to collaborate with you. So thank you very much. I was in time.
Thank you, Spiros. Thank you very much. The future of the seaports comes through the AI-based services, cognitive services that will make the shipping and maritime industry smart, cognitive, and provide access to information to all the stakeholders. One source of information comes from IoT sensors, IoT devices that can provide vast amounts of data. So, Carlos, let's hear about ASSIST-IoT and how data-driven services are handled through the project.
Okay, thank you, Christos, for the introduction. So let's go ahead. So I'm going to make a presentation related with ASSIST-IoT project. I'm coordinating ASSIST-IoT, a part of being one of the researchers participating also in DataPorts. So regarding ASSIST-IoT, as we are going to focus right now, the presentation is, the idea is how data is playing a role in the core aspect of ASSIST-IoT. This core aspect of ASSIST-IoT is the next generation IoT. And here in ASSIST-IoT, we have different challenges. And these challenges is, first of all, data is the new oil. Okay, and we will have to pay the price inside the architecture that we are developing in ASSIST-IoT. In ASSIST-IoT, we are experiencing that there's still reluctance on sharing data, and in the case of ASSIST-IoT, we are facing it in the different pilots. Or although we are improving, we have the challenge of interoperability, mainly interoperability among different devices, heterogeneous devices, different stakeholders working and dealing with the devices. And of course, one of the key challenges is the efficiency, how to move data to the cloud, to the edge nodes, and so on. So you will see that ASSIST-IoT, or the idea of ASSIST-IoT is we are data sources, but in the project, but we have to handle and we have to deal with this data that we are generating. And one of the problems of this efficiency, this interoperability, is that there is a lack of standards and common approaches. Okay, each deployment, each pilot, each use case, anything that is related with the next generation IoT always have a piece of, let's say, vendor ownership. So we have to go to this standardization and a common approach. And in the industry, as we will see in the different use cases, is focused on their own business, and they want to solve the problem. So it's not going straight, let's say, one step forward in order to improve things. So we have seen opportunities for this introduction of data in next generation IoT. One is related with DataPorts, in which we are working, another one is related with ASSIST-IoT. So one of the opportunities is that cognitive services, reuse of cognitive services is possible, and the introducing of data sovereignty in cloud-native architectures is also a possibility. And this is one of the core elements, the goal objectives of ASSIST-IoT. So ASSIST-IoT is a project that belongs to the cluster of next generation IoT, and especially to the tactile IoT. It's a project that is funded. It's a project that is funded in the framework of the call ICT 56. It's a research and innovation action. We are right now in the middle of the project in month 18, and we are having our review in a couple of weeks. So we have 15 partners of 7 countries. I will go later on to this, and we are having different enablers that will be the ones who will be supporting this data management, this data sovereignty, this use of data, and everything will be introduced in what we call a blueprint of the next generation IoT architecture. That it's a multi-plane oriented architecture. We will see it in the next slide. That is completely aligned with the standard 3D architecture of IoT. Okay, we provide support for different enablers, always considering that we are using a smart network infrastructure with low latency capabilities. We are working in ASSIST-IoT with TSN and with 5G networking. And the main idea is that we are not going to have intelligence centralized. As in IoT, we are having each time more and more intelligent devices that are deployed in the smart components. That smart components is the far edge elements, even the devices, and we are transferring intelligence closer to the edge. So trying to orchestrate the different intelligence service and try to manage the data close to the event. So these data-driven artificial intelligence cognitive services deployed closer to where things are happening they are key for the maritime ports industry. So this is the architecture that we are, or the ASSIST-IoT approach that has led to the architecture that we are developing, in which we have a multi-plane reference approach, in which we have horizontal planes and vertical planes. The horizontal planes, the goal is to provide different capabilities, and the vertical plane, the idea is to support the different required cross-plane technologies. Regarding data management, the key core enablers goal, that is that are the ones that are provided by the horizontal planes, is to support different innovative interaction, warranty data governance, provide secure tactile support for real-time application, having the data to have low latency, and facilitate distributed artificial intelligence. So the traversal enablers will focus on exploit specific functionalities and provide a high potential of modularity and adaptability. So this is very academical. I say this is very, let's focus us in a very abstract way. But if we go to the details, this is the specific architecture vision in which we have defined different technical components that have in the horizontal planes, horizontal layer, different traversal functionalities. And the idea is that this architecture is as much decentralized as possible. So the architecture can be deployed in the cloud, but it can be deployed also in a far edge node, in a small device. So it's based in hyperconnectivity and interoperability, because we are going to handle standard data all along the pilot and the different use cases. And the idea is to have context awareness in order that we are able to handle and to manage different contexts, and that it is provided to the users that are developing the application. So this distributed and the decentralized intelligence require also distributed data protection and differential privacy depending on where we are placing the data and what we are doing. So these human-machine interfaces and the human-machine interfaces for collaboration and interaction. We will see in one of the use cases for the maritime industry that augmented reality is one of the key interfaces that we are using. So we take a look, the three verticals, the three application domains in which we are working in ASSIST-IoT. One is smart safety at work that can be applied also for the maritime industry, cohesive vehicle monitoring and diagnostics, and the one that is relevant for the presentation of today is port automation. So the ASSIST-IoT architecture. So I will not bore you too much with the different technical details, but the idea is that we are developing different essential and complementary enablers that are separated from the physical layer, from what is the hardware container. They should be resilient, and they have to be easily adaptable to changes. We have decided to package the different enablers in Helm charts. We have decided to package the different enablers in Helm charts. And we have a flow of the encapsulated enablers as services. They are composable into different concrete and modular deployments, and they are flexible and decentralized. So some of this technology, we have used Kubernetes and light Kubernetes, and they are ready to be deployed in edge and constrained devices, but they can be deployed also in the cloud. So they are completely built in open standards, so they can be adaptable to other projects and other different deployments. So in the case of maritime industry, the idea is to deploy them in what we call nano edge nodes or the IoT smart devices. So in the In the vertical of port automation or the maritime industry, we have deployed 3 use cases. We have other use cases for the automotive industry, and other use cases for smart safety at work. And the majority of the use cases that we have developed, or we are developing in ASSIST-IoT, are related with automation of container terminals, environments in which a huge amount of data is being generated. We participated in the past. Some of the people that is right now making the presentation in a project that was finished in 2020 that is called Transport in Transport, in which we also did some work related with container terminals. And additionally, in InterIoT and in Pixel, other 2 projects, we also were dealing with this. Why? Because there is a strong interest or strong research interest in all the huge amount of data that is generated by container handling equipment. Okay, so one of the use cases is the idea of cooperation between edge container handling equipment. So here we have the use case in which a truck must pick a container of the yard stack. So there is a need of having a mutual position and data about the piece that is going to be retrieved, and understand if this piece is received from a central location. Security and latency issues are a must, because we cannot have delays, because then we may have a problem of interoperability and the synchronization. So the idea in ASSIST-IoT is to allow the automated communication between the truck and the crane for self-alignment and be able to allocate the different elements. Here we are working with LiDAR components and also with ultra-wideband in order to detect presence and to manage. We have edge nodes deployed in the container, in the truck, and also in the CHA, and in order to handle this information, also including the part of security and privacy of data. And the amount of data that is being generated in this movement of containers is incredibly huge. So the driver can now know which bay and height it must be aligned with. It will go to wherever he has to go, and can visualize the whole operation without exchanging in real time any kind of data with a central location. So everything will be managed on the edge. Okay. Another use case related with container handler equipment automation is the RTG control using remote augmented reality, thanks to artificial intelligence cognitive service. So this is one of the current bottlenecks in every container terminal, is the handling or the remote operation of cranes like RTGs and proper recognition of the different containers. So the point is that several equipment has to collaborate to train the different algorithms that have to improve the process. Here we count with the participation of Con Cranes, that is one of the largest manufacturers of cranes in the world. Okay, it's located in Finland, and the idea is that there will be an operator that using a desktop will be able to handle the RTG without being close to the RTG. So here it's extremely important that the data is flowing in real time from the crane to the interface that is being handled by the operator. And here we are working with 5G in order to provide low latency and be able to create what is called the tactile internet paradigm. So this is one of the screenshots. So the idea is that these enablers have been delivered in the Malta Freeport container terminal, and the idea is to be able to recognize the container, the spreader, and which one will be the one that has to be managed by the element. Everything handled by the different edge nodes. Another one, and the last use case that we are managing and with a huge amount of data, is that in the same way that we have Google Maps for a normal, let's say, navigation of a city, in a country, in wherever place we want to go, with roads, highways, and so on. In a container terminal, we need the same thing. Okay, so ASSIST-IoT will help and is helping providing the data from the different trucks, containers, RTGs, cranes, and so on, to be able to provide this navigation inside a container terminal. This one is also the Malta Freeport terminal. And with this exchange of information in real time, huge data exchange of information, we will be able to develop these cognitive services close to the edge and close to the events in order to support all the things that we are doing in the project. So these are the partners that are making ASSIST-IoT possible. Okay, we have UPV that is the coordinator. We have different stakeholders, like for example, Terminal Link, that is the owner or the manager of the Malta Freeport terminal, container terminal in Malta. We also have Mostostal, that is a largest constructing company in Poland. We also have Tutronic and Ford that are providing, and also Concranes with the cranes, Ford and Tutronic that are providing the automotive use case in the project. So in ASSIST-IoT, one of the things that we are doing is we are having 2 open calls. One was already announced the results last week, and we are launching the second open call of ASSIST-IoT, but because one of the interests that we have in ASSIST-IoT is to create an ecosystem of different SMEs and universities, research centers that are using our technology and are developing new applications from these verticals and for other verticals in which they are using. So the idea is that all of you stay tuned to the ASSIST-IoT social network links and also to the website, because in a couple of weeks, a second open call will be officially launched and new proposals will be accepted for the project in order to be included as third parties in the consortium. So thank you very much. And Christos, I hope I have been on time.
Yes, great. Thank you, Carlos, for your presentation. Thank you all for your presentations. What we have seen today is 4 different complementary approaches, complementary architectures, exploiting data, creating services, creating value, creating and shaping the future. Exploiting data, offering AI-based user services that will provide information. It will provide knowledge, and this, in my opinion, is the key point. The knowledge is something that is needed to transform shipping and maritime industry into the future. We have seen in these 4 presentations the opportunities and the challenges. One challenge that I see is the need of data. What challenges? What other challenges do you think that should be overcome in order to be ready in the future? Santiago, please.
Yeah, if I may start. Yeah, I think it's a good question. So I believe one of the main issues with sharing data is sometimes that this was pointed out in some of the presentations, the reluctancy of sharing data, since it contains the know-how and all the knowledge of the companies that has created and has originated that data, which is something very understandable. So the challenge is to really give one of the main challenges is really to give trust and confidence to people using data platforms and exchanging data. Since otherwise, if we are not able to provide trust, no one is going to want to share the data. So we have to make all our efforts, both technically and operational, to generate this trust in the solutions that we build or that we propose. Okay, and if we generate this trust, then we can offer some appealing services. So it's something more attractive to the end users, and we can take benefit of that. But I would say that's one of the main challenges in the data platforms. Okay, and especially in ports.
Very good point, indeed. And shipping and maritime industry is very cautious about the sensitivity of the data. All data owners are, of course, and the competitive advantage is a blocking factor, as a matter of fact. But the technologies are here, the solutions are here. I think that all of the researchers, all of us needed to focus on the awareness of the data owners in order to make them understand of the technologies that are capable to ensure trust, as Santiago very well said, and security. Dora, what's your opinion on that?
I think one of the biggest issues that we also see from our perspective is also the heterogeneity of data. So like you get them, what do you do with them? How do you process them? Because there are so many different processes and so many different ways of collecting them for so many different schemes to be that each partner complies to, etc. So like that's why we are exploring now possibilities of how can we unify this in order to make this process of knowledge exchange and collaboration smoother and easier, because each one is using and complies to different schemes. So this is also one challenge. And I don't know if you also saw, like in the end, regarding data, for example, the simplest with the SDA, we still have to upload documents. So these documents contain data, but then still we need to put in place a backbone infrastructure in order to check what is in these documents, etc., etc. So like there is a complexity also on the on the data themselves and what they represent and how they are collected and how do you process them as well.
Complexity and heterogeneity of data is very common, and it's something that all projects and all solutions need to face. And Santiago mentioned in his presentation the semantic interoperability that all of us need to create some sort of common language, common data catalogs. So everyone that wishes to get on board, at least to be able to speak the same language. Spiros. About the challenges, we all pinpoint the opportunities, yes. And the opportunities is very clear. How you believe the challenges should be addressed, and how close or how far we are from finding solutions to these challenges.
Okay, so we talked about the issue from the data perspective. Regarding, I would talk about the models that are created based on this data and the AI models, for instance. The AI is a big field. It has a lot of tools and technology. Some of the areas have been working really well, like in the computer vision, like the convolution neural networks, for instance, or when it comes to visuals or sound or things like that. There are some other areas where AI still needs to showcase, a valid business case. So a lot of the things that we are doing is experimentation, and the problem is that the maritime industry doesn't have the time, or the expertise, or the resources to do this experimentation. So I think it's part of our job to do these collaborations with the companies and showcase this added value. And by even showcasing the use case, it's very important for the maritime industry to see the added value and where we're heading. So in order also to be more competitive, because AI is the future, actually is the present. So this is our job, to experiment and play with AI, to validate and benchmark and try more. The other thing about the data is, as I said before, we have the concept of the digital twins. This is very important. Also, as I said in my presentation, there is a problem with training the models that you don't actually have the data. For instance, if you want to model collisions, or if you are creating a vessel and you need to see the best design, and so you need to know how the energy components fit together. You cannot pay millions of dollars and euros to find the optimal solution. So digital twins will play a very significant role in addressing these challenges, I believe. So we should focus more on research on that, and will also generate data that can be used to train data. However, the creation and the training of the actual digital twins need to happen on ground truth observation. So a collaboration needs to happen between the industry and the research. That's why I believe BDVA and the European data space are so important in this aspect.
You know, data owners, well, we can find many data users, but not many data owners and data providers. So
Yes.
we need these services that we create as projects and as other projects as well, to make them understand about the benefits, and that the solutions exist, and they are safe, and they can trust them, and they can benefit from them. Carlos, data from IoT devices can provide valuable information. Vast amounts of data can be provided by IoT devices. Most of them are not under GDPR regulation, or not that sensitive, one might say. Do you think that the end users, whereas the port authorities or any other end user, have done the step forward of adopting such solutions? Are we there yet?
Yeah, actually, the point with the IoT devices is they are generating the data, and you are bringing the data to the IoT platform that you are using. You may have the IoT platform in the edge node. You may have the IoT platform in the cloud node. Typically, the IoT devices generate the data, and the data is treated by the stakeholder that is managing that device. So the compliance with GDPR or any kind of regulation that is in place is depending on the one who is managing the devices. So in my opinion, port authorities are aware. The majority of them used to be public companies or public institutions, depending on the national governments, and they actually know which is the problem of not managing properly this data and not following GDPR and existing regulations. So one of the reasons that sometimes they are delaying not using certain devices or generating certain kind of data is that they are not so sure on how to handle, let's say, I will not use the word legally, but handling the data properly. So the idea here is mainly that when this data is generated, for example, in the framework of a private company, for example, a container terminal, there this data is generated, and it has to be compliant with the regulation. And in my opinion, I would say that all the companies that public or private that with whom we have been working in different projects in Greece, Spain, France, Italy, Slovenia, different countries, all of them are compliant with this. So data sovereignty and data privacy and this kind of managing of all this data is being compliant. Other thing is that when data is not being managed by big companies, managed by small companies, and they, for example, are deploying something and they are not meeting that. But I have to say that all the European companies with whom we have been working, all of them were compliant with this.
It is really important, and it is great that all 4 projects have port authorities in our consortium, and they are very close to the solutions that are given by the projects. It is a good thing that all researchers that we are here today speak the same language, understand the same challenges, and we work, I am saying, towards finding solutions or complementary solutions to address these challenges. And this was the purpose of this workshop, the joining forces. So DataPorts, Cyrene, VesselAI, and ASSIST-IoT, through such workshops and other events that we plan or been together, so that we work together. We actually join forces to address the challenges and create the future, the future of the seaports, in order to become smart and cognitive. So I would like to, since I don't see any questions from the chat, from the audience, I would like to thank you all for being here today. I would like to thank Santiago Cáceres, Dora Kalipolitou, Spiros Mouzakitis, and Carlos Palau for your excellent presentations. I would like to thank the audience, the participants. I would like to thank, of course, the DataWeek organizers for giving us the opportunity for all of us to be here and present our visions for the future. I may say that it is a common vision that we work together to address it, to find solution, and hopefully in the near future, all these architectures, all these services will be complementary and be used by the port authorities or the shipping industry in general. So thank you all for being here today.
Thank you very much.
Thank you.
Thank you,
Have a good
Christos.
day.
Thank you. Bye.
Thank you for
Bye-bye.
inviting us. Bye-bye.